rudder and keel. But if we have retractable appendages, or those that are not in the center line, like double rudder, bilge boats, we have to measure this separately. And I don't know if you actually have any boat having like this, when you have there are a couple of measurements you need for the center boat, which may go south from the fixed keel, or which may go south from the hull itself. And then there are a couple of measurements that need to be taken for these center boats. I don't know how many boats you generally have experience, probably some center boats, but
Not really.
not really. The other thing is, the other thing is that when you have a double rudder,
This is common.
this is common. So we cannot measure this in the offset file, because offset file is supposed to be symmetrical around the center line, and you cannot skull scan this part, this section. Instead, you have
Well,
to,
you can, but
You
then
can.
you have to remove it.
yeah, I mean, in general, in the offset file, you have to define it with a couple of measurements, with basically what is important. You need the center of gravity supposition where, in relation to the boat it is, span, how the height of this, root chord and thickness, stiff chord and thickness. Basically, you are always getting some trapezoidal form, because on the end what is calculated is the lateral area and the volume. And so, of course, sometimes the rudder is not just shaped like this, but then you have to be smart enough and, let's say, to estimate the actual area of the rudder with the actual to match it with this trapezoidal area. And then when you enter distance from the center line and angle, you are, as soon as these numbers are entered, the VPP will assume that this is a double rudder. And if you put this on the 0, then can be external single rudder, that is transom hang rudder or something like this, that is also not in the offset file.
Can you back one
Yeah.
slide? Is this data in offset file has influence on the stability? Or not?
Yes.
It's not in the offset file.
It's not in the file.
Because when you declare a center board, then you need to enter also the weight of the center board and the vertical displacement. And so the VPP, when doing the stability calculations, assumes the center board to be in the lower position upwind and in the upper position downwind.
And then
If owner declare to fix position in the
Yeah.
lower,
Now,
only
so
the
then,
lower.
then you have to include it in
in
the
the
offset
offset
file.
file, then it's like fixed. Then it's
Okay.
not anymore center board.
It's like a fixed key.
okay.
But then it needs to be included in the offsets, because then the VPP otherwise ignores it completely.
And then when doing inclining with the center board has to be right out. Then we have these bilge boards. This is the sometimes called canard.
Sorry, Zoran, could you go back one slide? Because I ran into this last week, the center board. One more, please. One of the parameters that's needed for centerboard boats is the weight of the board.
Yeah.
So this is a potential problem, to measure the weight of the board when it's installed in the boat.
Yes.
So, how do you get that?
I mean, frankly, as I told you, I never had experience of measuring things like this, but I would assume that depending on the type and the model, you can get accurate enough data from designer or someone to understand what it is. Or even if you have some plans, you can always take some measurements, depending of course on the shape, and take some measurements, measure the volume, calculate the volume. You need some hydrostatics calculation, and then knowing the material, check what would be the weight of this thing.
This is a potential pitfall, ladies and gentlemen, because these things are never the same.
It's the more difficult item is to measure exactly the draft when the board is down, especially in these pivoting boards that come out from the keel. Because when the boat is ashore, the center board is in, and there is no way.
No, but what I do is I make sure that the boat is up, and you get to it when the boat is out of the water. You make sure the travel lift slings are as short as possible from the boatyard. You lift it up and you say, gentlemen, please lower that board.
Okay.
Lift it up so that you can get to that condition there.
Yeah, and then you can measure the.
Then you can at least measure that. However, again, you're left with weight and not knowing. You're also left with knowing where the center of gravity of that board is, because you don't know the weight. So these are all a little bit creative. People.
No, I mean, you always have sometimes you always have the things that you need to rely on the design values, to rely on rely on some measurements, estimations, calculations, but you obviously cannot really measure. And I don't know, Nicola can tell us this has been like this in the beginning. I don't know how, if there is a way that we can improve the measurement of this and say, okay, we want to measure it like this, we are measuring now in the future like this. To go to vice versa, basically to measure and to make the stability with the center board down, and then to tell the BPP only that this is going up when selling down. But this is something that is not
easier.
Making problem, making it easier.
Well, but my point is that everybody in this room is smart. Right? We're all smart. We're all smart.
No, our phones are smart.
And therefore, you have to think about this. And sometimes you have to get creative. In looking at the geometry, in trying to get the dimensions as best you can. As Zoran says, you inquire from the designer or the builder, what is the material that this thing is made of? If it's hollow, is it completely hollow? Because oftentimes, they'll put, like in the case of the 50-some foot boat that I'm doing, that board is made of aluminum. And then they put some weight in it that's at the bottom in order for it to give it weight to drop. And when I asked the designer how much weight, he said, oh, I don't know, 300 kilos.
You have some systems to pull it up and or down. And then this is that gives you an indication on whether it's
No, because it's hinged.
Like,
It's hinged.
exactly.
Yeah.
And
So-
therefore, you know where you are pulling it up from. And
You could do some
and
clever.
you can check whether it's going down or not.
You could do some moment calculations, yes, provided that you could get to the system. On large cruising boats, you can't even get to this, right? Because it's buried somewhere in a nice wood frame case, right? And you don't want to tear apart the guy's furniture just to get to this measurement. It's difficult. Anyway, so be smart. Try to get to this as best you can. Maybe there's no rule on it, in other words. So
No, I
you
mean,
know,
generally, as I said, this is probably easier, but the principle is the same. You don't have the shape of the rudder purely trapezoidal like this, but you estimate the best as you can the actual shape of this to get the same area and the same volume. So
Yeah.
this is very neat. I mean, all these calculations are not science fiction, are not rocket science. It is basically all the simple weights, center of effort, pure, let's say, elementary school mathematics. It's not, but it's more the way to how to find a way to apply it and how to do something. I mean, it's,
so with CG, for example, if you knew that this thing was uniform, you'd find it to be more or less in the geometric middle, wouldn't you? And then if you knew that there was weight in it, you know that it would be lower than that. And then maybe you can do some calculations.
I mean, theoretically, you may have, let's say, with both like this, overall weight together with the center board, and then you may have, I don't know, you may have drawings or something to calculate the volume of the boat without the center board, and then from that, trying to find the difference. This is one of the possibilities. But for this you need some naval architecture background and do some.
the problem of the center boards exists especially in sport boats, I think.
Yeah.
And
But also big newer offshore yachts have those center boards when you have canting keels.
The canting keel is it's a
Well, no, but when you have a canting keel,
Yeah.
then you have a dagger board. with
that dagger board is probably pretty easy, and on a dagger board you don't need a weight. You need a span, core, thickness, and angle, or stuff like this.
but Zoran, one question.
Yeah.
If ORC investigates influence of these data of center boards in ORC International Certificate and ORC Club, because for ORC Club this data can miss or not.
No. I mean,
Because, for example, we have ORC Sport Boat Championship from 3 years, yeah? And they are allowed two certificates, club and international. And if ORC investigates accuracy or differences between two
No.
certificates,
understand.
ORC club, and for the same boat,
Yeah, I don't know.
different
But
data, exactly
No.
measured, or
Let me explain like this. If you are talking about different source international ORC club, from the VPP point and rating point of view, as I said yesterday, it's completely the same.
yes, but I
From the
indicate
source of the-
this point of
I agree.
measurement of
And for
center
the
boards.
source of the measurement, if you're using something that is estimation, of course, you will probably not get the same. We just finalized the new set of the rules for the sport boat in 2017. It's not yet fully published. We are waiting to publish together with notice of race for the championship in Latvia. And we said